Hello and welcome to a lesson on applications of solving equations. So we've taken a couple of days or a couple of topics to discuss equations, their solutions, and the steps we need to take in order to solve. Again, all the equations we've been solving have been linear equations, so in general, we were looking for one solution. Still doing the same thing in this particular topic. We're just going to look at some different ways in which we can apply the solving process. So we're going to look at having to translate words into a mathematical sentence that we can then solve. We're going to get some geometric examples. We're going to look at some consecutive integers, but just different ways to apply the solving process. So generally, when you're looking at applications, you're looking at word problems, and I know word problems can be a little challenging. Math is challenging on its own if we have to take the words, turn it into math, and then solve from there. Again, it can pose a bit of a challenge. And in particular, it's challenging because there isn't one way to solve every problem, but there is a general strategy that we can take when we approach word problems. So first, and this may sound silly, but first thing we need to do is read the problem. Maybe we need to read it a second or a third time so that we understand what the problem is giving us and what the problem is asking for. And the thing that it's asking for is going to help us define a variable for our situation. So read the problem so that we can define a variable. And then we're going to mark the text along the way. If we want to, we can underline things that seem important, or we can highlight. And then if we want, we can also organize the information into a list, or we can draw a picture or make a table, or whatever is helpful for you to organize the information. Or if underlining and highlighting or whatever was enough for you, then that would be fine. Again, these are just some general strategies. The hard part is going to be the fourth thing that we have to do, well, the fourth bullet point that I put here, which is writing an equation that models or represents the scenario that we are given. Because if we write the wrong equation, even if we solve it correctly, we're going to get the wrong answer. Okay, so we need to make sure that our equation represents and models the scenario that we're given. The solving piece, that should be the review. So we're going to solve. And the last thing is, once we've solved, because we're going to have some context here, we want to make sure that we answer in a way that makes sense, and we want to make sure that we get an answer that makes sense. So solve and make sure the answer makes sense for the problem that we're dealing with. Okay? So we're going to start with some translation examples because, in my opinion, they are the easiest because the equation is there in words. We just have to translate it into a mathematical equation. Okay? So, first example says 5 times the sum of a number and 5 times the sum of 3 and twice a number. I swear I can read. 5 times the sum of 3 and twice a number is 70. And they're asking us to find the number. Okay, so we're translating this portion here into an equation. Now, before we do that, it says to find the number. So what do you want to call it? The number that we're looking for? Since it's our unknown, it's going to be the variable that we define in this situation. And you can call it whatever you want. I'm going to call it n for number. Seems kind of reasonable. Okay? So now let's go back and just translate what we're given here. So the first thing it says is 5 times. 5 times means 5 is going to be multiplied by something. So I'm going to put 5 outside of a parentheses, and what's going to come in the parentheses is next, okay? So 5 times means multiply 5 by something, so 5 in parentheses does that. Now it says 5 times the sum, and the sum means we're going to be adding. So we're multiplying 5 by this sum of things that we're adding, and what we're adding is 3. So that's going to go here, and twice a number. So twice a number, the number we're looking for is going to be 2n. Twice means multiply by 2. And then we have is, and is always going to be our equal sign. And the last part's pretty easy to translate. It says 70, so 70 is going to come over here. And just so I can have color coordination, let me call the number n over here. Okay, so 5 times, again, 5 multiplied by. The sum means we're adding whatever we're multiplying by 5, and the things we're adding are 3 and twice our number. So 3 and 2n, twice our number. is our equal sign, and then 70. And now we have our equation to solve. So from here, we're going to, let me just write this all in one color. We want to simplify on the left here so we can distribute the 5. That's going to give me 15 plus 10n equal to 70. And now I can get n by itself. So I'm going to subtract 15 from both sides. That cancels that out. And now I'm left with 10n on this side equal to 70 minus 15 is going to give me 55. And then to get rid of times 10, I'm going to divide both sides by 10. So that's going to reduce out to 1. So we are left with here 1n equal to 55 over 10. Now 55 over 10 reduces. 5 is going to go into 55 11 times, and it's going to go into 10 twice. So 11 halves, or if you prefer the decimal, 2 goes into 11 5 times with 1 out of 2 remaining, so 5.5. Now if you don't want to do that work in your head or by hand, 55 over 10, there's your decimal, 5.5, or if you want the reduced fraction, 11 halves. Okay, so Desmos will do that. And so we would just box that in here because this has a little bit of context. We're going to say the number is 11 halves, or 5.5, same number, but whichever one you prefer you can use, or if you wanted to state both, that's good too. Okay, so just a translating problem. Let's try another one, same kind of deal. It says 2 more than a number is 12 less than 3 times the number, and our job again is to find the number. So I'm going to call again my number that I'm looking for, n, and now I'm going to go back and try to translate. So 2 more than means we're going to add 2. So we're adding 2 to something, 2 plus something, or like, okay, let me just show you here. If I have 10 and I put a plus 2 over here, I get 12. If I have 10 and I put a plus 2 over here, I still get 12. So when we're adding our number, it doesn't matter if I add it first or add it after. If we're subtracting, however, if I did 2 minus 10 or 10 minus 2, 2 minus 10 is negative 8, but 10 minus 2 is positive 8. So it's going to make a difference with subtraction, but not addition. It's called the commutative property. We can change the order in which we add and still get the same thing, but we cannot change the order in which we subtract and get the same thing. Okay, so that's a little bit of background there. So I'm going to go 2 more than means add 2 to something. So 2 plus. It's 2 more than a number. So my number I called n, and then it says is our equal sign, and then it says 12 less than. So 12 less than means I have to subtract 12 from something, right? If I was 50 and I wanted to be 12 less, I would have to subtract the 12 to get to 38. So 12 is going to be subtracted from, so I put a little bit of space here. It's going to be subtracted from, I'm running out of colors here. Let's see. Let's go with a custom color. How about this super bright red? 3 times my number is what it's going to be, 3 less than. So, or 12 less than. 3 times my number, so that's going to be 3n. So we have 2 more than a number is 12 less than 3 times the number is 3n. And there is my equation to solve. Let me just get rid of all these dots. Okay, so now we're ready to solve. So let me just write this all in one color. This is 2 plus n equals 3n minus 12. So nothing to simplify on the left, nothing to simplify on the right. There's nothing to distribute. There are no like terms on either side, but I do have variables on both sides. I want to get those together. This time I'm going to choose to subtract this n. That way I'm left with positive n's, so that's going to cancel there. And that's going to leave me 2 on this side. I thought I changed. That's going to leave me 2 on this side, and then if I have 3 n's but I take 1 n away, I'm left with 2n, and then I still have a minus 12. Now I'm going to add 12 to both sides so that I can get that n by itself. That cancels those. So then I have 2 and 12 gives me 14. my equal sign, and I still have 2n on that side. And now to get n by itself, I'm going to divide by 2, divide by 2, and there it is. N is equal to 7. So the number is 7. Okay, not so bad, hopefully. Maybe it's been a little while since you've done these, but hopefully it's manageable for you. All right, there's one here. If you feel like you can do this, then give it a try. Otherwise, it says 3 less than twice a number is 19, and our job again is to find the number. So just for some variety, I'm going to call my number x this time. Again, you can use whatever variable you want. So it starts with 3 less than. So 3 less than means I'm subtracting 3 from something. What am I subtracting 3 from? I'm subtracting it from twice a number. So that's going to be 2n. Again, 3 less than is subtract 3 from. Twice my number is 2n. My is my equal sign. And then 19, that's pretty easy to translate. 19 is 19. Okay, so there's our equation. And this one doesn't have to be simplified. Doesn't have variables on both sides. It's totally ready to be solved. So I'm going to write it all in one color here. If 2n minus 3 equals 19, we're ready to solve. So we're going to start by adding 3 to both sides. That's going to leave me with 2n equals 19 and 3 is 22. Then I can divide both sides by 2. And I'm left with my solution, n equals 11. So the number is 11. Okay? Not horrible. Again, that's my skewed math teacher opinion, but hopefully this is manageable for you as well. Okay? Sorry, this was just looking like it was connected to that circle. All right, so those are some translation examples where you're literally going to take the words and make a math sentence out of it. Next, we're going to look at a few that aren't as straightforward because it's not just a translation problem. It's going to take a little more thinking. So next we're looking at what we call a consecutive integer problem. It says the sum of 3 consecutive integers is 60, and we are to find the integers. Integers, if you aren't aware, those are positive and negative whole numbers. So -3, -2, -1, 0, 1, 2, 3, and so on, forever in both directions. No fractions or decimals in there, just all the positive and negative whole numbers are the integers. Okay, so we're actually looking for 3 of them, and they're to be consecutive. So do you know what consecutive means? Well, consecutive numbers would be like 1, then 2, then 3, then 4, and 5, and so on. Numbers that go on forever. One after another after another. So consecutive numbers are one after another. So, sorry, I'm going to need a little more space. So 1, 2, 3, 4, and so on. Those are consecutive numbers. Okay? So we're looking for 3 of them. And it says the sum of those 3 consecutive integers is going to be 60. So we're going to be adding 3 consecutive numbers, and they have to make a total of 60. Okay? So we need some variables here. We've got a first number that we don't know. We've got a second number that we don't know. And we've got a third number that we don't know. Now, does that mean we want 3 different variables? No. I don't know about you, but I can't solve one equation that has 3 different variables in it. In order to solve equations with 3 variables, you'd have to have 3 equations, and it makes a system, and it's a much more complicated process. So these all have to be in terms of 1 variable. So let's just say the number, don't write this because it's incorrect, but I'm just going to say, like, what if my first number was 14, then my next number would have to be 15, and my next number would have to be 16, right? Consecutive numbers. Or if my first number was 10, this would be 11, and this would be 12. Or if the first one was 5, this would be 6, and this would be 7, right? So if I don't know my first number, I can call it x. What would the next number have to be? What am I doing to go from 14 to 15, or 10 to 11, or 5 to 6, or from x to my next number? All I'm doing is adding 1, right? Add 1 here, add 1 here, add 1 here. So my next number, if my first number is x, my next number would have to be x plus 1. And then what about my next number? Remember, it's got to be in terms of x. So, well, to get from 6 to 7, or 11 to 12, or 15 to 16, I'm just adding 1 again. So if I added 1 again, then the 1 and the 1 could go together, so this number would have to be x plus 2. It would have to be 2 away from the first number that we started with, if that makes sense. So we're going to call these numbers, that's a giant eraser, we're going to say for any consecutive numbers, doesn't matter what your consecutive numbers are, if you call the first one x, the second one would be 1 more, the next one would be 2 more than the first, the next one would be 3 more than the first, and it would just continue on for depending on how many consecutive numbers you had. So we're going to call the first number x, the second one we're looking for x plus 1, and the third one we're looking for x plus 2. So now it says we have these 3 consecutive integers and we want to find the sum of them, and that sum is, there's our equal sign, and it's 60. Okay, so if I take my first integer x, add it to my next integer, which was x plus 1, and add that to my next integer, which was x plus 2, this says that all of those have to add up to 60 all together. And there's our equation, okay? So this can be simplified. We have definitely some like terms that we can combine on the left. So an x and another x and another x. Well, that's 3 x's all together. If I add those 3 x's together, right, that's 3 x's. And then if I put together the 1 here and the 2 here, that gives me a plus 3. So 3x plus 3 is equal to, I still have a 60 on the other side. And now I'm ready to solve. So if I subtract 3 from both sides, then I have left 3x on this side equal to 57. And now I can divide both sides by 3. And that reduces to 1x equal to 57 divided by 3 is going to be 19. Let's just double check that. 57 divided by 3 is 19. So that means our first number is 19, and then our next number has to be 20, and our next number has to be 21. So the numbers are 19, 20, and 21. Okay, and they're integers, they're not fractions, so this works out. The integers are 19, 20, 21. And you could easily check that. If you add those 3 together, you are in fact going to get a sum of 60. Okay? So again, hopefully manageable. Last ones we're going to look at are some geometric examples. I saved the toughest one for last. So let's look at number 4 before we deal with the fun one. The length of a rectangle is 4 more than its width. It says to find the dimensions of the rectangle if its perimeter is 48 inches. So it says we've got a rectangle here. Let's draw this out. I like to draw when I can. All right, a rectangle is easy enough. It says that the length of the rectangle is 4 more than the width, and we're going to be looking for both dimensions, both the length and the width. But just like before, I don't want to have multiple variables here. So we have to decide if the length is the variable or if the width is the variable. Which one is truly unknown, or which one do we know nothing about? Okay? So it says the length is 4 more than the width, which means I know something about the length. It's 4 more than the width. But do I know anything, or does it give me anything about the width? It does not, which means the width is going to be our variable. And just so I know exactly what I've solved for, I'm going to call it W. Okay? So let's put a W here, and let's put a W here, because if it's a rectangle, those two widths will be the same. Now the length, which is the other dimension that I haven't labeled yet, that length is 4 more than the width. So if the length is 4 more than that width, then whatever it is, whatever that width is, 4 more means add 4 to it. So for the length, we can put a W plus 4. And again, a W plus 4. And then it tells me that the perimeter is 48 inches. So the perimeter is 48. And so I think I have enough information here to make an equation. Do you know how to find the perimeter for a rectangle? I'm hoping. Okay, for the perimeter of a rectangle, you're just adding up all of the sides. So you add all sides to find perimeter. So in this case, if I add the w and the w and the w plus 4 and the w plus 4, there's my 1, 2, 3, 4 sides. Okay, if I add all 4 of those sides together, according to this problem, that perimeter, the sum of all those sides, has to equal 48. So now I have my equation. So that's 1, 2, 3, 4 w's plus the 4 here and the 4 here makes 8 altogether, and that has to equal 48. So now I can subtract 8 from both sides because this thing is ready to be solved. So then 4w has to equal 40. And now I can divide both sides by 4. And so now I have 1w all by itself equal to 40 divided by 4 is 10. So that means the width of my rectangle is 10. And if the length was 4 more, then the length has to be 14. So my width is 10, and this was inches, right? So it's going to be 10 inches, and my length is 4 more, so that would be 14 inches. And again, you could verify if you wanted to. You can put in a 10 here, and a 10 here, and a 14 here, and a 14 here, and altogether that's going to go ahead and give you that perimeter of 48. So it all works, and we're, oops, going backwards. All right, there we go. All right, last one. Again, a geometric problem, but this one is going to be a little more challenging. So it says the second angle of a triangle is 4 times as large as the first. The third angle, typo, that's supposed to be singular. The third angle is 5 more than the sum of the other two. It says find the measure of the second angle. Okay, so let's draw this out. Not really fair. I have a cheat tool to make a nice perfect triangle for me, but it says the second angle is 4 times as large as the first. The third is 5 more than the sum of the other two. Find the measure of the second angle. So we're looking for the measure of the second angle, but that's really not going to be the variable in this case. There are 3 unknown angles in any triangle. In this particular triangle, 3 unknown, but they tell us information about 2 of the angles. It tells me the second angle is 4 times as large as the first. It tells me the third one is 5 more than the sum of the other two, but I don't know anything about the first. So the first angle, that's the one that's going to be the variable. The first angle, let's call it A. A for, oops, my draw tool is on. A for angle, okay? So the first angle is A. Let's just call this angle A. And this is not necessarily drawn to scale. This could be way off. I just need some place to organize my information. All right, now it tells me that the second angle, here, let's go ahead and label these angles. Let's call this the first angle. Let's call this the second angle. And let's call this the third angle. Okay, so we've got the first angle in there as A. It says that the second angle is 4 times as large as the first. So if the first one is A, the second one is 4 times as large. That makes it 4A. And now it says the third angle is 5 more than the sum of the other two. So 5 more then means add 5. Add 5 to the sum of the other two. The sum of the other two means I'd have to add the 4A and the A. Now I put parentheses in there because the sum of those two means I would add those first, but it's not really going to affect what we're doing here. So the sum, 5 more than the sum of the other two, means I'm going to be adding the other two, 4A and A, and then adding 5 to that. So there's the sum of the other two angles, and then 5 more means plus 5. So there's the information. Now the question is, how do I make an equation out of this? Well, it does take a little bit of background knowledge about triangles, in particular the angles in a triangle. Do any of you remember the relationship between the angles in a triangle, or what's true about any 3 angles in a triangle? Well, the 3 angles of any triangle will always add up to 180 degrees. So the 3 angles in a triangle, 3 angles in any triangle add to a sum of 180 degrees. So that means I can take my first angle and my second angle and my third angle, 4a plus 5. I can add those together and make them equal a total of 180 degrees, and there's my equation. So obviously we have some simplifying to do. I've got 1a plus 4 more a's, so that's 5 a's, plus 4 more, that's 9, plus 1 more is 10. So I have 10a, oh my gosh, 10a altogether. Let me not do blue. 5 million times a charm. Let's stay with pink. 10a altogether plus, we have this 5 to bring down and nothing to combine with it, equal to 180. Now we're ready to solve. So let me subtract 5 from both sides. That's going to give me 10a equal to 175. And then I can divide both sides by 10. Divide by 10. And so a is going to equal 175 divided by 10. And again, you can have a reduced fraction or decimal. 175 divided by 10. Is 17.5, or if you want the decimal, 35 halves, although I think for angle measurements the decimal is going to be a little more appropriate. So 17.5, and that means our first angle here is 17.5 degrees. Now the second angle, that's the one it asked for. The measure of the second angle was the actual question here. So the second angle is 4 times that. So 4 times the 17.5. 17.5 times 4 is going to be 70. So 70 degrees here. And if it asked, then we would add up the other two. So we'd add the 17.5. We'd add the 70. And then 5 more than that, 5 more the sum of those two, means this last angle would have to be 92.5 degrees. And then just to be safe, if we added 92.5 and 17.5 and the last angle, which was 70, we should get a total of 180 degrees, and we do. So just a way for us to check our work. So our second angle is 70 degrees. The second angle is 70 degrees. Okay, so that did require a little bit of background knowledge on some geometry. Whatever I give you in the practice to work on, or whatever I might put on a quiz, I would not ask you for any outside information. So I could ask you to do another perimeter of a rectangle problem, or another angle problem where you would be required to know that the sum of the angles in a triangle is 180. If I put anything else on a quiz or practice that required a different formula that I haven't discussed with you, then it would probably be a bonus question. Okay, so the only formulas you are required to know are the ones that I would show you, of course. So don't think you have to go out and be looking up formulas. Okay, if it's not a formula we've discussed, I'm not going to just throw it at you. Okay, so hopefully you'll be okay for the practice problems, but as always, if you need some extra help, then just reach out. All right, guys, take care.